All right, this next video is 100% for your information. What we're going to find is that the concave up is the second derivative is positive and concave down is the first or the second derivative is negative. I just want to do a quick video to explain why this is so we're not just memorizing it. Again, if you want to skip this video, that's up to you, but I want just for my conscious, I want to make sure that everybody has heard this. So that wants to hear it. So for concave up, what you would do is you would look at the derivatives of the function. Specifically, you would look at the m tangents, which are, of course, the slope of our tangent line is our derivative. So if I look at the tangent lines here, I start off with a negative tangent line. So this would be f prime is some negative value. Then I go to f prime is equal to 0, and then I go to f prime is positive slope, and then you'll notice that these little f primes get more and more positive. So what happens is if I go from left to right, I see that I'm going from decreasing to 0 to positive to steeper and steeper positive. So what we would say is we would say that the first derivative is increasing. So our first derivative function is increasing because it goes from negative to 0 to positive and then more and more steep, more and more positive. So for a concave function, we see that the definition is going to say that if the function is concave up, then the first derivative is increasing. And that is just a function of looking at the tangent lines for the concave up function. You could do exactly the same analysis for concave down. For concave down, you would say, okay, here my derivative is positive, then it becomes a little more shallow, then it goes to 0, and then it goes negative, and then it continues going negative, negative, negative. So you're switching from positive to negative, so your derivative, your first derivative, is decreasing. And that's exactly what the definition of concave down says. It says that the function is concave downward if the first derivative is decreasing. Now, this has an implication for how we're going to determine where the function is concave up and concave down. Because remember that when we were looking at is the function increasing, we added a prime and we drew this number line for the first derivative. And that told us if the function was increasing. Well, now with concavity, we're interested in the derivative. Is the derivative increasing? So for the derivative increasing, we need to look at the second derivative. So again, for the function, we looked at the first derivative. We added a prime basically and looked at that. So the same thing is going to happen for the f prime. To figure out if f prime is increasing, we're going to need to look at the second derivative. So that's your quick for your information why we're looking at the second derivative for concavity. It's because of this definition and what we know about how to identify if our derivative or function is increasing.